My name is Razan Al-Talib.
My name is Matthew Weekly.
I'm Sean O'Malia, and our project was the referee whistle for deaf athletes.
Participating in sports with a hearing disability can provide particularly interesting challenges for both the deaf player and for the referee. Some of these cases can include when the referee blows the whistle to stop play in any sort of sport. Maybe the deaf player can't hear it, and maybe they don't notice from surrounding events. So sometimes in these cases, if they don't see like a light or another player stopping them, they could potentially be injured in the play of the sport.
Our goal was to design and implement a system to mitigate the disadvantages introduced by the hearing disability without supplying the deaf player with an unfair advantage. The system needed to be easy to use and fit into the existing game structure without major alterations to the rules of the game. The system needs to be durable, to survive repeated impacts without injuring any of the participants, as well as being comfortable enough for the player to wear for the duration of a game.
The system has two main components, a transmitter for the referee and a receiver for the athlete. Both sides of the system run completely off of battery power and rechargeable via a standard mini USB cable, which can also flash software updates to each half of the system. The referee transmitter connects to the player's receiver via a 2.4 GHz RF signal, which can transmit a signal halfway across a FIFA regulations soccer field. The receiver vibrates immediately after the button is pressed. Each half of the system has a power status LED and a dedicated on and off switch on the exterior of the case. The referee's transmitter incorporates a button which can be attached to the whistle, so the deaf player can be notified of a whistle blow at the same time as other players. Both of these blocks serve the same functionality. One is for the transmitter and one for the receiver. They both contain a 4.2-volt lithium polymer rechargeable battery that is connected to a charging circuit. The battery can be charged using a mini USB cable. This block also contains a voltage regulator circuit that will convert the voltage of the battery to constant 3.3 volts that can be used to power the other parts of the system. Both parts of the system have a separate control block. This block basically serves as an on-off switch to the system. It contains a slide switch, a green LED, and a voltage routing circuit. When the switch is turned on, the green LED turns on, and a 3.3 volt is supplied from the battery block and goes to other parts of the system. When the switch is turned off, the green LED turns off and no voltage is supplied to any part of the system.
Overall, the microcontroller transmitter is a relatively simple block. It handles the whistle detection, power management, and data transmission. The whistle detection is done through a button that is going to be attached to the whistle that the referee will hold, and that is connected to an input pin on the microcontroller. The power management is done by the state switching in the state machine, and data transmission is handled through the RF transmitter in the code. Similarly to the transmitter, the receiver has a relatively simple functionality in that it has signal detection through the RF transceiver. It has power management done by the state machine in the code, and when notified, it sends a signal to the motor control board. The code for the transmitter is written in C and compiled via a makefile on the command line. What it does is it actively scans for a button press, and when it detects one, it starts an interrupt and transmits a frame to the receiver. When it's done transmitting, it goes back to actively scanning for the button press again. Similarly, the receiver code is also written in C and compiled with the make file via the command line. What it does is it actively listens for a radio frequency signal, and when it detects one, an interrupt is called and it vibrates the motor for 1 second. When the motor is done vibrating, it exits the interrupt and returns to scanning for a signal.
This block contains a vibrating motor and a current amplifying circuit that amplifies the weak current that comes from the microcontroller in order to drive the motor. When no current comes from the microcontroller, the circuit acts like an open switch to protect the motor.
The enclosures are designed to protect the entire system. There is an enclosure for the transmitter and the receiver. Both the transmitter and receiver enclosures are very similar, differing only in whether they contain a motor or have the wires for the whistle button coming out of the case. The enclosures are designed to withstand the required temperature and drop height. The enclosure was 3D printed and designed in SolidWorks. Our project sponsor specified that our project needed to meet 6 requirements. It needed to be wearable, it needed to be easy to use, it needed to work for the entirety of a match, it needed to be safe to use, it needed to not give the deaf player an unfair advantage over the hearing players, and it needed to be reprogrammable for future scaling. So from these requirements, we made 10 engineering requirements. We required that the system have a battery life of at least 3 hours, or about the duration of a match. It needed to be able to survive a 5-meter drop in order to simulate a field impact. This is the follow-up to the drop test video. This is just showing that the cases are still intact. There's no sharp edges. This is the receiver side. Same thing, no sharp edges. The case is still intact. And the entire system still functions. It needed to have a 60-meter range, which is half of a FIFA regulation soccer field. We are standing at midfield on a regulation soccer field. Razan is holding the transmitter. I'm holding the receiver. When Razan presses the button, the receiver will vibrate. Now, I'm going to walk to the end line down there, and Razan will then send the signal to me. So here's the end line of the field. Now Razan is going to send the signal. It needed to survive temperatures between 0 degrees Celsius and 30 degrees Celsius. This is the heating part of the device. We have a setup here with a heat gun, and having run it for a bit, one can see that it reaches above 30 degrees Celsius. So we're going to put the thermometer back in the box, and we'll put both sides of the system in the box. And we will come back in about 10 minutes. It is currently 4:32. So it has been 10 minutes. Now, pulling temperature of thermometer. It is, well, it is well above 30. The red line is off the scale. So, pull out the receiver. Here's the transmitter. So, they both power on, and System still works.
This is a requirement video for the referee whistle for deaf athletes, and it will be demonstrating the thermal capabilities of the system. For this test, I will be putting the transmitter and the receiver in the freezer overnight. It currently is 11:15 p.m. So I'm going to take these, put them in the freezer until I wake up. It is now about 6:46 a.m., so I'm going to check on the system again. Here we are. Time to power them. Both still power on, and they both still function.
It needs to have a power LED to indicate when the system is on. The entire system needs to cost less than $250, and that includes both the receiver and transmitter together. Both sides of the system need to be able to receive updates to the firmware via USB. Both sides of the system need to have a dedicated power switch so that the system can easily be turned on and off. The batteries for both sides of the system need to be rechargeable via USB, and the entire weight of the system needs to be less than 500 grams. So the way the system works is that the referee, when they want to blow the whistle to blow a play dead, to call a foul, for whatever reason, they simply hit a button on the whistle, and the player will have a device similar to this strapped to their upper arm, and the device will vibrate, alerting the player that the play is dead. So, to show how the system would work, turn on both the transmitter and the receiver, and then, so the referee wants to alert the deaf player that the play is dead, hits the button, and now the vibration is slightly longer than the actual button press to make sure that the player notices that the button has been pressed, the whistle has been blown, and the play is dead.
This video demonstrates two project features. The first one is the fast signal transmission, and the second one that the device does not give an advantage to the deaf athlete. I am gonna represent the referee. I have the whistle and the transmitter with me. Sean will represent a regular athlete, and Matt will represent a deaf athlete. He's gonna wear a noise cancelling headphones so he's not able to listen to the whistle. Matt and Sean will now walk away from me, and I'm gonna try to test this 3 different ways, but Sean and Matt will not be do not know what test I'm gonna perform first. So the first test that I'm gonna perform is I'm just gonna blow the whistle. Sean is the only one who noticed the notification. Test number 2 will be both the whistle and the transmitter at the same time. Both Matt and Sean noticed the noise and the vibration in the receiver. Test number 3 will be just the transmitter. Matt is the only one who noticed the vibration. And I'm gonna test this again, like the whistle and the transmitter again. Both of them noticed the notification. Going forward, the current design serves a solid prototype to build off. For the next iterations, the goal is to make the hardware simpler and smaller. This includes combining all the circuits into one PCB and making the case smaller.
Another improvement would be to design an automatic sensor for the whistle to notify the transmitter of when to start a transmission. Another addition could be to modify the software to allow greater system flexibility and scalability, including the ability to receive and differentiate signals from either a coach and then a coach versus a referee, and also allowing multiple deaf players to receive a signal from the same referee device.